Mars is not slowly dying. It is erasing its own past, a cosmic sculptor reshaping its destiny. One of its moons is falling apart right now, and compelling evidence suggests it has already destroyed others before. What if Mars has been repeating this cycle for billions of years, a silent testament to cosmic resilience, and we are only seeing the end of its latest iteration? Most people think Mars is dead. A cold, silent world, a red desert frozen in time, a planet that failed to sustain life. This perception, while understandable given its current arid state, overlooks a profound and dynamic history. But what if that picture is completely wrong? What if Mars is not a graveyard, but a crime scene, or perhaps, a cosmic laboratory of perpetual change? High above that quiet red surface, something is happening right now, something slow, inevitable, and profoundly violent. One of Mars' moons, Phobos, is dying. Not metaphorically, but literally. It is spiraling inward, losing altitude year after year, dragged by invisible gravitational forces it cannot escape. This process, known as tidal decay, is a fundamental aspect of orbital mechanics. In about 50 million years, a mere blink of an eye in cosmic time, Phobos will be torn apart. It will be shredded into billions of fragments, stretched into a dark, ghostly ring around the planet, a temporary crown of debris. This dramatic event is not a sudden catastrophe but the culmination of eons of gravitational interaction. That alone is unsettling, a stark reminder of the universe's relentless power. But here is the part that should stop you cold, a revelation that reshapes our understanding of Martian history. Phobos may not be the first moon Mars has lost. And it may not be the last. Some scientists, driven by intriguing geological and orbital anomalies, believe Mars has lived through a cycle of moons. This is a repeating pattern of creation, destruction, and rebirth, a cosmic ballet where moons are born, pulled inward, ripped apart into rings, and then reborn again from their own remains. This cycle may have repeated over and over for billions of years. If this idea is true, then Mars is not a static, failed planet. It is a world shaped by relentless change, a dynamic system constantly recycling its celestial companions. It is a world that has lost entire moons, possibly 3, 5, maybe even 7 of them, long before humans ever looked up at the sky. And suddenly, Phobos doesn't look like an anomaly, a unique victim of cosmic fate. It looks like a survivor, the latest in a long lineage. Or perhaps, it is the final chapter of a much older, grander story, a testament to the planet's enduring, cyclical nature. When we imagine destruction, we often envision an ending, a finality. But the universe rarely works that way. In space, destruction is often just a transition, a violent prelude to a new beginning. When a moon is torn apart, about 80% of its mass may be lost forever, crashing into the planet below or dispersing into space. However, the remaining 20% can slowly gather, collide, and reassemble into something new. This new body would be smaller, weaker, and perhaps less majestic, but still alive, still orbiting. This process of reaccretion is a fundamental mechanism in planetary science, observed in various forms across the cosmos. That means Mars may not just lose moons, it may recycle them. This concept challenges how we think about stability, not just in astronomy, but in life itself. We are often taught to chase permanence, permanent success, permanent growth, permanent security. Yet the universe seems to operate on a different rule. Everything moves in cycles, from the birth and death of stars to the ebb and flow of galaxies. Everything that survives does so by adapting to collapse, by finding new forms and new equilibria. Mars didn't fight these cycles, it endured them, becoming a master of cosmic reinvention. Today, Phobos and Deimos are tiny, misshapen shadows of what may have once existed. They are not majestic, nor are they powerful in the way Earth's moon is. But they are still here, orbiting Mars, albeit on borrowed time. And that alone tells us something important. Survival does not always mean staying big or powerful. Sometimes it means lasting long enough to become something else entirely. The red planet we see today may be the quiet aftermath of immense loss, lost oceans, lost atmospheres, and possibly lost moons. But within that loss lies a pattern, a rhythm, a cosmic reminder that nothing truly disappears without leaving something behind. The universe is a meticulous record keeper, its history etched into the very fabric of space and time. And if Mars, a planet stripped nearly bare, can still carry the fingerprints of its past, its ancient stories whispered through its geology and its moons, what does that say about us? What lessons can we glean from this distant, red world about resilience and transformation? If this story resonates with you, if you're curious about what Mars can teach us about collapse, reinvention, and resilience, consider subscribing to the channel. Your support helps us continue uncovering stories that don't just explain the universe, but help us understand ourselves and our place within its grand, cyclical narrative. Before we continue, here's a question for you, our fellow space enthusiasts. Which do you believe is more powerful? A. Stability that never changes, or B. The ability to rebuild after destruction? Comment A or B below. Your answer might reveal more about your mindset than you think. If part 1 asked us to look up at the sky, then this part asks us to look down, into the rocks, the dust, and the quiet geological memory of Mars itself. Because if Mars truly lost moons, the evidence would not be written in the sky anymore. It would be written in stone, preserved in the planet's ancient crust. That crucial evidence may lie in a place called Gale Crater, a vast impact basin approximately 154 kilometers in diameter. Billions of years ago, Gale Crater was not the dry, wind-scoured basin we see today. It was once home to liquid water, to lakes that persisted long enough to leave behind layered sediments, a discovery that profoundly reshaped our understanding of ancient Mars. But what the Curiosity rover found there went even further, revealing patterns that should not exist on a world with no significant tides. Curiosity, a marvel of robotic engineering, discovered alternating layers of light and dark sediment near Mount Sharp, the central peak of Gale Crater. These layers were stacked with an almost rhythmic precision, a geological heartbeat from the deep past. To a trained eye, these layers were hauntingly familiar. On Earth, similar formations are known as tidal rhythmites, sedimentary records created when water repeatedly advances and retreats under the gravitational pull of a moon. These rhythmites are invaluable tools for paleoceanographers, providing insights into ancient tidal cycles and lunar distances. Mars, however, should not have tides like that. Not today, at least. Phobos and Deimos, Mars's current moons, are far too small and too distant to produce meaningful tidal forces, especially in a lake. Their gravitational influence is negligible compared to Earth's moon. Yet the pattern was there, preserved like a fossilized heartbeat, undeniable and perplexing. Even more striking than the presence of these rhythmites was the timing they implied. By meticulously measuring the spacing between these alternating layers, scientists inferred a repeating cycle of roughly 30 days. This single number, derived from geological strata, changes everything we thought we knew about ancient Mars. Phobos completes an orbit in under 8 hours, a remarkably fast pace. Deimos takes about 30 hours. Neither comes close to a month-long cycle. If the rhythm recorded in Gale Crater truly reflects tides, then the gravitational force behind it could not have been either of Mars' current moons. The implication is unavoidable: another, much larger moon must have existed in Mars's ancient past. From that inferred orbital period, scientists could work backward, using the laws of celestial mechanics. A 30-day orbit places this hypothetical moon at a distance of roughly 10,000 kilometers from Mars, about 3 times the planet's radius. This distance is close enough to exert strong gravitational influence, yet far enough to remain stable, at least for a significant period. Then came the harder question: mass. To generate tides capable of shaping sediment in an ancient Martian lake, this moon would need to be at least 18 times more massive than Phobos. In human terms, that sounds enormous, a truly substantial celestial body. In cosmic terms, however, it is still modest. This would still not be a moon like Earth's, which is a quarter the size of its planet. It would have been closer to a large asteroid, perhaps 60 kilometers across, airless, silent, and lifeless, but gravitationally potent. But size alone is not what matters here, influence is. This lost moon, if it existed, would have been powerful enough to move water on another world, to raise and lower ancient Martian lakes, and to leave behind a signature that could survive 3.8 billion years of erosion, impacts, and planetary change. Of course, science demands skepticism, and alternative explanations were rigorously explored. Seasonal climate cycles or glacial processes can sometimes mimic layered sediments. Mars' axial tilt is known to be chaotic, capable of producing extreme environmental shifts over long timescales. However, these alternatives struggle to match the regularity, symmetry, and precise timing observed at Gale Crater. No supporting evidence for glaciers has been found in the relevant strata, and seasonal explanations fail to reproduce the precise, consistent cadence of the rhythmites. What remains is not absolute certainty, science rarely offers that, but something rarer and more valuable: a compelling possibility, supported by robust data and careful analysis. If this interpretation is correct, then the surface of Mars is quietly telling us that its history was once shaped by a moon that no longer exists. A body that rose and set in the ancient Martian sky, pulled water back and forth, and then vanished, not suddenly, but gradually, as gravity rewrote its fate. There is something profoundly human about this idea. That the most important influences in a system are not always the ones that survive. That something can shape an entire era, leave permanent marks, and still disappear without a trace in the present. Mars does not remember this moon in motion, it remembers it in layers, in the silent, fossilized rhythm of its ancient tides. And perhaps that is how all deep histories are preserved, not in what remains visible, but in what quietly shaped everything before it was gone. If the lost moon of Mars truly existed, then its story does not end with disappearance. It ends with profound consequence, for in the universe, nothing of significance vanishes without reshaping what comes after. The cycle of Martian moons is a testament to this cosmic principle, a continuous narrative of transformation. To understand how this cycle could begin, we must step back to a far more violent chapter in Martian history. Mars is a planet of imbalance. Its northern hemisphere lies low and smooth, a vast, flat plain, while the southern hemisphere stands higher, older, and heavily scarred by impacts. This striking global asymmetry, known as the Martian dichotomy, is unlike anything we see on Earth, and it has long demanded an explanation. One possibility, still unproven, but profoundly compelling and widely discussed among planetary scientists, is that Mars once endured a colossal impact early in its history. Such an impact would not need to rival the one that formed Earth's moon, which involved a Mars-sized body. Mars is smaller, less geologically active, and unable to erase ancient scars through plate tectonics. A sufficiently large collision could have excavated much of the northern hemisphere, redistributed enormous amounts of material, and ejected a significant amount of debris into orbit. From that debris, a moon could have formed, not stable forever, but stable long enough to matter, long enough to leave its mark in Gale Crater. And if that moon formed close to Mars, its fate would have been sealed from the beginning, a ticking cosmic clock. Mars rotates slowly, completing a rotation in just over 24 hours. When a moon orbits faster than its planet rotates, gravity works against it in a subtle but relentless way. The tidal bulge raised on the planet by the moon's gravity lags behind the moon's position, pulling backward instead of forward. This constant backward tug saps orbital energy from the moon. The orbit shrinks. Over millions of years, the moon spirals inward, not dramatically, not suddenly, but relentlessly. This is not catastrophe, it is inevitability, a fundamental consequence of tidal physics. That is why the hypothetical ancient moon did not survive. It was not destroyed by chance or a random impact. It was dismantled by physics, a victim of the very gravitational forces that bound it to Mars. As it crossed the Roche limit, the critical distance where a celestial body's own gravity can no longer hold it together against the planet's tidal forces, it would have been torn apart. This event would have spread its material into a magnificent, albeit temporary, ring that briefly encircled the planet. Most of that material would have rained down onto the surface, creating impact scars, or dissipated into space. But some fraction, small, stubborn, persistent, would have remained in orbit long enough to collide, clump, and assemble again, forming a new, smaller moon. This is where the cycle reveals its deeper meaning and its profound implications for planetary evolution. Each iteration produces something smaller than before. Each rebirth carries less mass, less influence, less presence. Yet it continues. The system does not reset to zero, it evolves downward, conserving what it can, adapting to its losses. Over time, this process may have repeated multiple times, gradually stepping down in scale until only Phobos and Deimos remained, tiny, irregular remnants of a much grander past. Seen this way, the moons of Mars are not failures or cosmic anomalies. They are survivors, the latest generation in a long line of celestial bodies that have danced this gravitational waltz. There is a quiet humility embedded in this cosmic process. The universe does not reward size alone, it rewards endurance. It allows systems to continue, not unchanged, but transformed. What matters is not preserving the original form, but preserving motion, memory, and momentum. Mars teaches us this without words. Through gravity. Through time. Through silence. Its moons may come and go, but the cycle continues, a profound lesson etched into the very fabric of the cosmos. The story of Mars and its lost moons is not just about astronomy, it is a reminder that nothing meaningful grows without change, and nothing enduring survives without adaptation. Moons were born, torn apart, and reborn, not because the system failed, but because it evolved. Mars teaches us that loss is not the opposite of progress, it is often the path to it. Even when most is gone, what remains can still shape the future. If this perspective inspired you, subscribe to the channel to support us in creating more stories that expand the mind, strengthen resilience, and reconnect us with the deeper rhythms of the universe. Join our community of space enthusiasts and let's continue exploring the cosmos together.